All right, let's do our last math lesson for the week. This is Patterns in Algebra 8-30, which is problems and puzzles. Now this is the stuff that I find the most fun because you're looking at patterns within problems, within figures, and you're coming up with formulas and then you're solving. So this is actually pretty cool. It's a great mind benders and brain teasers. Let's check out number one. If this pattern continues, how many times does the number 49 appear in the triangle? So we've got this triangle-shaped pattern going on here. And we want to know how many times would 49 appear. Now what I could do is I could say, okay, well it looks like these are going up by 3 each time, and I could write out each one until I had 49. But it's going to take an entire page. It's going to take a long time. So what I'm going to do is I'm going to create an input-output T-chart. And that's going to help me to solve this one really efficiently here. So in my input-output T-chart, the first term, 1, that one there appears just once, and the value is 1. The second term is 4, and it's twice. The third term is 7. The fourth term is 10. And the fifth term is 13. Already from these here, I can see that I've got a nice even gap. That's plus 3. That's plus 3. That's plus 3. So my coefficient for the formula is simply going to be 3 times the number plus or subtract something. So let's see, 3 times 1 is 3, and I want my output to be 1, so I'm going to subtract 2. 3 times 1 is 3, subtract 2 is 1. 3 times 2 is 6, subtract 2 is 4. 3 times 3 is 9, subtract 2 is 7. So this is the formula I'm working from here. My expression is 3n subtract 2. Now I want to know how many times 49 will appear in the triangle, which basically is what term number is the value 49. And I'm going to figure that out by posing it like this. 3 times some term number subtract 2 equals 49. I want to make sure that I'm preserving equality. So I'm going to add 2 to both sides. So 3n subtract 2 minus 2, plus 2, equals 49 plus 2. 3n equals 51. N is equal to, now 51 divided by 3, I played a lot of darts when I was a kid, so I can actually do that in my head. 51 divided by 3 is 17. So n then is 17. How many times does the number 49 appear in the triangle? If I were to draw it out, the number 49 would appear 17 times. Pretty cool, huh? Let's take a look at number 2. We're going to do the exact same procedure for the second one. We're going to look at each pattern. We're going to write a sequence, write a formula, and say whether the figure has 100 blocks, if any of these figures will have 100 blocks. So first off, let's write our sequence for this one here. Our sequence for this one is 4, 6, 8. Well, that's simple enough. There's 4 blocks, then 6 blocks, then 8 blocks. The input-output T-chart that's going to help us do the number, or the formula is 1 is 4, 2 is 6, 3 is 8. Those are my inputs and my outputs. What's the gap? Well, the gap on the output, the difference between 4 and 6 is plus 2. Difference between 6 and 8 is plus 2. So my coefficient for my variable is going to be 2. So let's come up with a formula. The formula is going to be 2n, and n being my variable. Now, I want my output to be 4, so 2 times 1 is 2, plus 2 more. So 2 times 1 is 2, plus 2 is 4. 2 times 2 is 4, plus 2 is 6. This is my formula for figure 1, figure 2, and figure 3 in question 1. Now, will any figure have 100 blocks? All I have to do is I have to use my formula and say, well, is there something that equals 100? And if so, what number? So 2n plus 2 equals 100. Preservation of equality means I'm going to subtract 2 from both sides, so 2n equals 98. That means n equals 98 divided by 2, which is 49. Yes, if I were to draw out 49 different figures, the 49th would have 100 blocks that makes it up. I'd like you to do the exact same thing with 2, 3, and 4. You're going to first write your sequence. Secondly, do a t-chart and create a formula. Thirdly, use your expression, your formula, equals 100, and see if there's a value for that n which would be true. If so, it will have 100 blocks. Okay? That's all you have to do for question 2. So pause the video here, do question 2, 3, and 4. If you get lost at any time, just rewind the video so you can watch part 1 over again. Okay, welcome back. Let's take a look at number 3. The title and labels for this graph are missing. Which of these events could it represent? Circle your answer and explain your reasoning. So we've got 2 choices. The first is the cost in dollars of renting a pair of skates for n hours. And the second one would be the volume in centimeters cubed of a cube with a side length of n centimeters. So if I look at the graph here, I can see that the gap between these points, the vertical gap, is from 6 to 10, from 10 to 14. The vertical gap is 4, which means my formula then would be 4 times a number. 4 times 1 is 4, and if I get to 6, that means it's 4n plus 2. Does that check out for the second one? 2 times 4 is 8, plus 2 is 10. Yeah, that's my formula for what's shown on this graph here, 4n plus 2. Now, would that make sense for a pair of skates rented for n hours, or for the volume of a cube? And I was thinking about this for a little bit, and I was like, okay, well, I know that the volume of a cube is a number that's times itself 3 times, right? It's cubed, right? So if I was taking a look at an example of 1 cubed equals 1 times 1 times 1, well, that would just be 1. My value then would be 1 and 1. And I'm looking at the graph here, and I've got the value of 1 and 6. So I don't think it could be the volume of a cube, which means it must be the cost of renting a pair of skates for n hours. That seems like a legitimate thing. So for the cost, it's 4 times the number of hours plus 2. Maybe the $2 is like a cleaning the skate surcharge or shoveling the ice. I don't know. What else could this graph represent? Add in your own title and labels to the graph. Now, there's any number of things that this linear graph could represent. The cost is increasing with each term. I was thinking about it. Maybe it's because I'm hungry, but I was like, well, maybe it's the cost of food per guest at a dinner party. So the cost of food per guest is 4 times the number of guests plus 2. That would work. So I'd have cost of food here, and this is the cost in dollars, and this is the guests. All right, there I've got my my graph labeled. Let's check out number 4. Complete the t-table. Now the t-table down here requires you to use exponents, squares, sorry, square numbers squared. Now this says write 2 different formulas for the number in the nth row of the t-table. So first we have to actually complete this t-table here. 2 squared is like 2 times 2. And 1 squared is like 1 times 1. So 2 times 2 is 4. 1 times 1 is 1. So 4 minus 1 is 3. 3 squared is 3 times 3. That's 9. Subtract 4. So that's 5. 4 squared is 4 times 4, which is 16. Subtract 9, which is 7. I'm starting to see a pattern emerge here. Let's keep going. 5 times 5 is 25. Subtract 16. Is that continuing the same pattern? 6 times 6 is 36. Subtract 25. What's the pattern that's going on here? Each one of these has got a gap of plus 2. You're like, well, you're just counting up by odd numbers. That's all you're doing. That's correct. 3, 5, 7, 9, 11, 13. Now the tougher part is writing a formula for the t-table here. Now, especially when we start looking at this one here, one of the formulas we could do is, if I'm looking at n being my variable here, and I replace this number 1 with an n, this is the same as saying 1 plus n squared plus n squared. Because whatever n is, this is simply 1 more than that. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. That's one way of looking at the formula. I found it easier to look at the formula the traditional way of saying, well, what's the gap? It's the gap times the variable. That's our coefficient. So 2n, if I look at my output here is 3, 2n plus 1. So that would be 2 times 2 is 4 plus 1 is 5. 2 times 3 is 6 plus 1 is 7. This is the one that I find to be simpler to use. That's just me. Part C says, will 2010 squared subtract 2009 squared be in the 2009th row or the 2010th row? How do you know? So looking at these, my first row, row 1, is 2 squared subtract 1 squared. So I've got 1 plus n is in my first row. So if I want 2010, that's equal to 1 plus n. That's 2010. So in this case, I know that it's going to be in the 2009th row, because that's 2009 plus 1 is 2010. Now we're going to use our formula to find out what this is going to be. Now looking at this one here, I could use my calculator and I could square both these numbers and subtract, or I can just simply substitute into this one. So I've got 2 times 2009 plus 1. 2 times 2000 is 4,000. 2 times 9 is 18, so that's 4,018 plus 1. 4,019. Go ahead, use your calculator and substitute in using this formula here, 2010 squared, subtract 2009 squared, and see if you also get 4,019. Let's jump down to the last question. So the last question again has 3 figures. This is kind of like question 1 and question 2, where we're simply looking at a pattern. Part A says write an expression for the perimeter of each figure. Now perimeter again is the outside edge. So I'm going to go around and I'm going to count up all of the lengths of the outside edge of each figure. I'm going to do a T-chart. Okay? So let's do my T-chart here, my input and my output. In figure 1, the perimeter, the outside edge is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the perimeter is 12. In figure 2, the perimeter is 5, and 5 more is 10, 11, 12, 13, 14. And in figure 3, the perimeter is 5 and 5 and 6. Okay, so that's 16 in total. Well, let's see what the gap is here. The gap between each one of these is plus 2. Could you use that to find out what the formula is? This is our coefficient. So the formula then is going to be 2 times the figure number. Now, my first one is 2 times 1 would be 2, and my output has to be 12. So it's 2 plus 10 is my constant. So 2 times 1 is 2, plus 10 is 12. 2 times 2 is 4, plus 10 is 14. 2 times 3 is 6, plus 10 is 16. So this is my expression which represents these figures. Which figure would represent a perimeter of 76? I'm going to substitute in, I'm going to say 2n plus 10 equals 76. I want you to work through this one, use preservation of equality, and figure out which figure is going to have 76 as a perimeter. Go ahead and do that one. That's all we have for this lesson. There's going to be a quick Google form quiz that follows this one here, because we've actually finished off everything we need to do for patterns in algebra in this unit. Way to go!